Hi guys, so we are in our new unit, yay us, on quadratics. Okay, so this is unit 7 here. We're going to start off 7a with key features of quadratic functions. By the end of this learning target, you should be able to graph as well as identify the key characteristics of quadratic functions. You should be able to find the axis of symmetry, the vertex, the x-intercepts, whether it has a minimum or a maximum, and other things related to our quadratic functions. Okay? So today we're going to start off with a little introduction. Okay? So we have already studied linear as well as exponential functions. Okay? These functions, they were relatively simple, right? Because they were always either increasing or decreasing, right? It was either going up, right? Whether it had a positive slope or it was growing exponentially, or it was decreasing for their whole domain. Okay. With this function, we're going to start to study other types of functions. This time we're focusing on quadratic functions, which we know is a type of polynomial function. Right? So the definition of a quadratic function is here. It's any function that can be placed in this form, y equals ax squared plus bx plus c. Okay, this here is the standard form of a quadratic. When we were learning how to classify polynomials, right, when our highest power or highest degree was 2, we knew that it was called a quadratic. Okay, some of the requirements is that a, right, our coefficient for x squared cannot be 0. However, b and c can be 0. Okay, so let's start thinking. Okay, so considering the definition for a quadratic function, we're going to answer these questions. Okay, so why is it important that this leading coefficient, right, is non-zero? Okay, so leading coefficient is our coefficient for our highest degree, right? So here it's represented by a here, and the definition is that a could not be 0. So why is it important that a cannot be 0? Okay, and the reason why is this, right? If the leading coefficient is 0, right, then the function would be 0x squared. Right, so if the coefficient for x squared here, this a, if it was 0, it would be 0x squared. Right, and if it was 0x squared, then we really don't need it at all. And what would happen then is this would not be here anymore, and it would be bx plus c, and it would make it no longer a quadratic. Right? Because if it was 0x squared, that term would not be here at all. Okay, which means that it would no longer have x to the second power. It would no longer be a quadratic. Instead, it would be bx plus c, and that would make it a line. Right? So then here, circling the choices below that are quadratic functions. Okay, so y equals x squared minus 3. Yep, this follows that pattern. Right? Y equals 1x squared plus 0x. That's why we don't see the x to the power of 1 minus 3. Okay. Y equals x cubed plus 2x squared minus 4. This is not a quadratic. Okay. Instead, this would be a cubic function. We learned that last unit when it was x to the third. Right, that's the highest degree. It'd be a cubic function. Okay. This one here, y equals x squared plus square root of x plus 7. This is not a quadratic function, and the reason why is because of this square root of x. And then the last one here is y equals 10 minus x squared. This is considered a quadratic, right? We could write it as y equals negative x squared plus 10. Then it follows the same pattern here. Okay. So see here, given the quadratic function y equals 10 minus 3x squared plus 7x, we're going to write it in standard form and then state the value of the leading coefficient. Okay, so if it's in standard form, we start with our highest power. Okay, so that's x to the second power. So this one comes first. So negative 3x squared. Then it's x to the power of 1, so plus 7x. And then since this 10 is positive, this constant is positive, it will be a plus 10. Right. The reason why it's important to write it in standard form is because when we start solving it and finding key features and things like that, it needs to be written in standard form so we know what A, B, and C is. Okay, and then the leading coefficient here. Leading coefficient, it's the coefficient for our highest degree. So here, negative 3x squared. So the coefficient here is negative 3. D here then asks us if f of x equals 2x squared minus 3x plus 1, we're going to find what the value of f of negative 2 is. Okay. So remember, this means that here, this negative 2 is our x value. And what we're going to do is evaluate the function. We learned this last semester. All we're going to do is take that negative 2 and plug it in wherever we see x. So here, plug it in where I see x. Okay, this is really asking, what is the y value when x is negative 2? Okay. Equals 2, and then I see an x, so I'm going to replace that with negative 2, and then square minus 3. I see another x, I'm going to replace it with negative 2 plus 1. Okay, and then all I need to solve. So first, according to order of operations, exponents comes first. Okay, negative 2 squared is negative 2 times negative 2. That gives me a positive 4. Okay, then I'm going to do multiplication next. So 2 times 4 is 8. Negative 3 times negative 2 is a positive 6. And then plus 1. Okay, and then last is addition. 8 plus 6 plus 1 equals 15. Okay, so this tells me that when x is negative 2, the y value is 15. So one of the points on this graph, right, points make the equation true, right, then it'll be on the graph. So negative 2 comma 15, if I graphed this original function, negative 2 comma 15 would be one of the points. Okay. So quadratics, okay, they still believe in similar ways to other functions, meaning they follow a pattern, right? We put in an x value, and we get out a y value. Okay. However, it just behaves differently from linear and exponential functions, right? So linear functions, they consistently add a number or subtract a number, and then exponential functions, we consistently multiply a number, right? However, with quadratics, our outputs end up repeating. Okay. So we're going to consider the simplest of all quadratic functions, f of x equals x squared. This is known as the parent function. Okay? All other quadratics follow the patterns of f of x equals x squared. Okay, so we're going to fill out this table below. Okay, what we're going to do is we're going to plug each of these x values in. Okay, so I'm going to plug in negative 3 in here. Okay, so negative 3 squared is negative 3 times negative 3, so that's 9. Okay, then I'm going to plug in negative 2 here. So negative 2 squared, negative 2 times negative 2 is positive 4. Okay, then I'm going to plug in negative 1 here. Negative 1 times negative 1 is positive 1. Okay, then I'm going to plug in 0 here. 0 squared, 0 times 0 is 0. Okay, and then I'm going to plug in 1 here. 1 squared, 1 times 1 is 1. Okay, plug in 2 squared, 2 times 2 is 4, and plug in 3 squared, 3 times 3 is 9. Okay, now I'm going to graph the function here. So negative 3 comma 9, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is negative 3, 9. Okay, then negative 2, 4, 1, 2, 1, 2, 3, 4. Then negative 1, 1, negative 1, 1. Okay, 0, 0, then 1, 1, 2, comma 4, 1, 2, 1, 2, 3, 4. And then 3 comma 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then I'm going to connect the dots. And as you see, quadratics make a U shape. Ooh. And then it asks, what is the range? Okay, so what is the y values of this function, right? So we're going to write it in interval notation. Okay, so y values, right, we know it goes up and down. Okay, so starting from the bottom, okay, this here has a y value of 0. And since it touches it, it's going to be a bracket. And then after that, it goes up and up and up and up. And then since there are arrows, it means it goes up forever towards positive infinity. Okay, so the range here is including 0 all the way to infinity. Okay? Another way to think about it, if it's in inequality notation, that means all of our y values are greater than, right? They're all higher. They're all greater than or equal to, because here it's equal to 0. Okay? So range expressed in two ways. This is interval notation. This is inequality notation. Okay, let's flip. Okay. So here we're going to use our calculator. We're going to help generate a table for x squared minus 2x minus 8. There isn't a lot of room here, so I'm going to do it on the side here. X, y. Okay. Since we haven't learned exactly how to graph it yet, we're just going to do some simple numbers. -3. Leave some space. You're going to need room. -2. Leave some space. -1. Leave some space. 0. 1, 2, and 3. Okay, so pause here. We're going to plug it in. Okay, so plug in -3 squared minus 2 times -3 minus 8. So -3 squared is 9. -2 times 9, positive 6 minus 8. 9 plus 6 minus 8 gives me 7. Okay, so can you do the rest of the table and then come check your answer? Okay, so do the rest of the table, come check your answer. So pause the video and then do the rest. Okay, and then here is your table. So we did the first one together. It was -3 comma 7. Then you should have gotten -2 comma 0, -1 comma -5, 0 comma -8, 1 comma -9, and 2 comma -8, and then last was 3 comma -5. Okay, then I took each of those x and y values and I plotted it here. Okay, and then what I recognized is that after the point 1 comma -9, it started repeating again, right? And so I got up to here, and then I realized it was all a mirror image of one another, right? This, if I reflected it over, it'd be here. This 2 points reflected it over, it'd be here. Here, if I reflected it over, then it would be here. And so that's how I got this point and this point, is because I started noticing a pattern, right? Is that it went 7, 0, -5, -8, -9, and then after that it started going backwards again, and it went to -8, -5, and so I assumed next it would be 0 and 7, and so that's how I got these 2 extra points here to complete my graph. Right. So then what is the range of this function? So range again is y values. We think up and down. Okay, so starting with the lowest point here, this is -9. Okay, and it includes it, so I'm going to put a bracket, and then it goes up forever, right? Up forever, so -9 towards infinity. Or if we wrote it in inequality notation, all of our y values are greater than or equal to -9. Okay. Here it asks for over what domain is the function increasing, where is it going up? Okay, so domain here is x values. So it's asking you, where's our x values where we are increasing? So here, from here on this right side, right, we see that from here to here, it is always going to go up. Okay, the x value here is 1 all the way, and it will keep going up and up forever. So from 1 to infinity, we are increasing. Okay, where does our parabola start to turn? Right, it is also known as the vertex or the minimum point. As you can see here, it's going down, and then once it hits here, it starts going up. So here, this is our vertex. It is our minimum. It's our lowest point. This point here is 1 comma 9. Sorry, 1 comma negative 9. Okay, and that is our turning point here. Okay, that axis of symmetry is where it is reflected. Okay, so as I said earlier, right, that pattern is after here it started repeating, right? So this here, this vertex, where this vertex x value is, this is where it starts being reflected. It is symmetrical. If I folded it on this line, it would be the same on both sides. Okay, this is a vertical line, so that means it's x equals. So what is the x value for this line? All of the points on this line have an x value of 1, right? 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, right? So everything on this has an x value of 1. The equation for this axis of symmetry is x equals 1. Okay. Then here we're asked what are the x-intercepts. So where does it cross the x-axis? So it crosses it here at -2, 0. Okay, and it crosses it here at 4, 0. Okay, these are known as the zeros of a function. We'll learn more about how to solve them when we get to 7c. Okay, why does it make sense? Right, it makes sense. This name makes sense, right? Because the y values of these points are zeros. Right? It's -2, 0, 4, 0. And that's why we call these x-intercepts zeros, because their y value is 0. Okay? So last one here. The quadratic function here has selected values shown in the table below. Where is the turning point? So when does it start then repeating itself? So here it has 4, 9, 12, 13, and then it goes 12, 9, 4, 2. So where's the middle point where they start repeating? Right here, right? Because everything after that, from this side it goes 12, 9, 4. From this side it goes 12, 9, 4. Okay, so the turning point here is 2, 13. This is our vertex. As we can see, all of the y values compared to this turning point is less than that. And so our range would be -infinity to 13. And it includes 13. Or another way to write it is that all of our y values are less than or equal to 13. And the reason why is because if I were to graph this, it would look something like this, where this turning point, this high point, would be 2, 13, and everything else is below that, right? It starts at 13 and everything else is less than that. Okay? So that's it for today. Hopefully you understand and are able to visualize quadratic functions a little bit better. Have a great rest of the day. Bye, guys.